So activity 5.2 continues on the bottom of page 406, where it says traveling at different speeds. You want to make a trip that's 200 miles on the New York State Thruway. The speed limit is 65 miles per hour, and then we're given some questions. Question starts with number 18. So it says if you maintain an average speed of 60 miles per hour, how long will it take to make the trip? So I feel like this 60 miles an hour is probably a key piece of information. We're given a formula that distance equals rate times time. So if I divide both sides by rate, I'll be left with just time, where time will equal distance divided by rate. So okay, so we're given a rate, 60 miles per hour, so we know R. We know the distance is 200 miles, so we can just divide 200 by 60 to get the time. So when we do the math, we're left with 3.33. So it's really 3.33 hours, or 3 1/3 hours. So I really should write the units here. 19 says travel time depends on the rate of speed at which you travel. Right? So they give us this function. T is a function of R, or time is a function of rate. And whereas to write an equation that defines the travel time, that's T, as a function of the average speed R. So we don't know what the speed is, so we'll use R for average speed, but we do know the distance is 200. So we'll do 200, right, that's our distance, divided by our speed, or our rate, which would be R. So we're left with 200 over R. So T equals 200 over R. That's our function. Question 20 says, okay, use the equation we just found, this 200 over R equals T, to fill in the table. So let's get our calculator out, right? We could plug in the 1 for R and do 200 divided by 1 is 200, and then 200 divided by 2 is 100, but we can also use our calculator. So let's open up our calculator. So I'm going to go to Y equals, and I'm going to enter 200 divided by R, or in this case we'll use X, right? So my Y is T and my X is R. And then I'm going to set up my table, right? So I'll go second window. I'm going to start at 0. I'll count by 1. And that will give me at least 1 through 5. So I press second and the graph key. And you can see, okay, when X is 1, my Y is 200. Right? When X is 2, my Y is 100. When X is 3, we have 66.67 and so on. So let's complete 1 through 5 now. And notice how we skipped 4. So we had 1, 2, 3, and then we jumped to 5. So we can ignore 4, 50. Then we jump to 10, and then 20. So instead of me having to keep hitting this down arrow button to go from 10 to 20 to 30, how about I go to my table set, right above window. So I press second, I press window, and I'll start at 0, but I'm going to count by 10 instead of counting by 1. So I change this to now we're going to count by 10s. Press second and graph, and now you can see, okay, 10, 20, 30, 40. So that's going to help us complete this table. So here's my table. And you'll notice as the rate is increasing, the time is decreasing. And that makes sense, right? The faster you travel, the quicker you'll get to your destination. Question 21. Complete the statements below. As the value of R increases, the value of T will decrease. As your speed increases, the travel time decreases. Let's move on. As the value of R gets closer to 0, the value of T, well, let's see what happens here. If we look at our equation here, right, if I put in 0 for R, right, that'd be 200 divided by 0. That's going to give me an error, so that's a problem. Okay, so I would say as the value of R gets closer to 0, our answer is going to go to basically infinity, right? We're going to get really big, right? As this number gets smaller and smaller and smaller, the value of T gets really big, but at some point we're going to get to a problem, right? We're going to get to some type of error. As you travel more slowly, the travel time will increase, of course, right? The slower you go, the longer it will take to get where you're going. What is the practical meaning of R equals 0 in the context of this situation? Well, think about it. If you're traveling 0 miles per hour your travel time will be infinity, right? You'll never get where you're going if you're traveling 0 miles per hour. What is the domain of this function? So remember, going back to this, here's my equation, right? T equals 200 divided by r. So we know r can never be 0, and we know a rate can't be negative. So let's go back to our question. The domain will be all real numbers except 0, right? R can never be 0. Right? So here's my domain. But the practical domain will just be r has to be just some number greater than 0, right? We know we can't have a negative rate. So I guess even more realistically, how fast can you travel on the highway? 65 miles an hour, if that's the speed limit. Maybe you do 70, 75, right? You're not going to travel 1 million miles per hour. So practical domain might be from some number greater than 0 to, say, perhaps you're a speed demon, maybe 80 miles per hour. So I might say r is somewhere between 0 and 80. Vertical asymptote? Well, remember, that's the exception to your domain. So the exception to the domain would be r equals 0. So the vertical asymptote will be r equals 0. So here's my the equation of my vertical asymptote. Then they give us the graph, right? They say here's the graph of t equals f of r over its practical domain. So it looks like they went from 0 to, say, 85. 26 says, okay, what's the practical meaning of the ordered pair 5, 4? So remember, if r represents the rate and t represents the time, well, if you're traveling at 5 miles per hour, it's going to take 40 hours to travel at 200 miles. Right? So if you travel at a rate of 5 miles per hour, right, that's the r, it will take 40 hours to travel 200 miles. Okay. Number 27, what's the practical meaning of the ordered pair 40, 5? So again, here's our graph, 40, 5. So if I'm traveling at a rate of 40 miles per hour, it will take 5 hours to travel 200 miles. Okay, so when we get to 27, right, so if you travel at a rate of 40 miles per hour, it will take 5 hours to travel 200 miles. So it says, what are the horizontal and vertical intercepts of the graph? Remember, intercepts where we cross the x and y axis. So let's take a look at our graph. So again, when I look at the graph, it doesn't appear that this graph is going to cross the y-axis or the t-axis, and this graph doesn't cross the r-axis or the x-axis. So there's really going to be no horizontal intercept, no vertical intercept. And if you think about how we find the vertical and horizontal intercept, if we look at the original equation, t equals 200 over r, right, to get the horizontal intercept, you plug in 0 for y and solve for x, and to get the vertical intercept, you plug in 0 for x and solve for y. So if I plug in 0 for r, I'd have 200 divided by 0. That's an error. So there's no vertical intercept. And if I plug in 0 for t, I would have r times 0 is 0, and then I'd have 0 equals 200. So there are no intercepts. Right? So when we get back down to question 28, the answer is there are none. Question 29, what is the horizontal asymptote? Remember, intercept is different than asymptote. Right? Asymptote's that imaginary line we get close to but never touch. It says use your table to look at what happens when t to t as r gets really big. Write the equation of the horizontal asymptote. Use the variables given in the problem. All right, so let's take out our calculator and let's go to our table. If I start at 0 but I count by, let's say I count by, I don't know, 200. We want to see what happens when x gets really big. Right? So I press second and graph, and you can see I'm at 1, I'm at 0.5, 0.3, 0.25, 0.2, 0.1. Right? You can see we're getting smaller and smaller. It looks to me like we're getting closer and closer to 0, but we never actually touch 0. Right? 0.09, 0.08, 0.06, 0.05. Right? We're getting closer and closer. Right? 0.00. But we never actually touch 0, right? I can keep going. As my x is getting really big or my r is getting really big, we're getting closer and closer to 0, but we never actually touch 0. And again, if I take a look at my graph, just go back, you can see, right? As r is getting really big, this line's going down. It's getting closer and closer and closer to 0, but we never actually touch 0. So that's a horizontal asymptote. So the equation of our horizontal asymptote would be r equals 0. I'm sorry. Yeah, right? I'm sorry, it would be t equals 0, right? T is approaching 0. I think that's it. All right, that completes this lesson.